A supercalifragilisticexpialidocious morning, our dear classmates and professors. In today's discussion, we will be discussing more about chemical industries. And the chemicals that we will be discussing are hydrochloric acid and sulfuric acid. But before that, may I encourage everyone to please listen attentively, and I hope you will learn something based on our discussions. Okay, so the contents of our discussions are the following. First, what is a chemical industry? Second, hydrochloric acid. So, may mga subparts siya. So, we have first, what is hydrochloric acid? The history of hydrochloric acid, its uses, the hydrochloric acid market, the manufacturer of the said acid, what are the raw materials in manufacturing the said acid, and the production process. And also, the same with the sulfuric acid. What comes in your mind when you hear the word chemical industry? Is chemical industry plays an important role in the economy? Or does it help the community people in their daily living? Just tune in and we will learn more about chemical industry in the succeeding slides. What is chemical industry? The chemical industry is one of the most diverse manufacturing industries and is concerned with the manufacture of wide variety of solid, liquid, and gaseous materials. The main raw materials of the chemical industry are water, air, salt, limestone, sulfur, and fossil fuel. The industry converts these materials into organic and inorganic industrial chemicals, ceramic products, petrochemicals, agrochemicals, polymers, and fragrances. Most of these products are largely used in manufacturing other items, while others can be used directly by consumers. Applications of chemical science have contributed significantly to the advancement of human civilization by providing a growing understanding and ability to manipulate chemical molecules. Chemistry controls the tastes and flavors of the food we eat, the scents we wear, the look and feel of our clothes, and how the world appears around us. Chemical behavior of the interaction of elements and molecules give us the energy we need to heat our homes, drive our cars, and to power our lives. This chemical behavior governs the distribution of the natural resources that we need and the industrial processes required to extract them. In return, we rely on chemistry to turn them into products, and we rely them on every day. Chemical industries are very important for the economy of any country. This is because these chemical industries supply the farmers pesticides and fertilizers, which are essential for crop growing. In this way, chemical industries contribute to agriculture and food self-sufficiency of every country. According to the report, the chemical industry touches nearly every good producing sector, making an estimated 5.7 trillion US dollar contribution to world gross domestic product or GDP through direct, indirect, and induced impacts, equivalent to 7% of the world's GDP and supporting 120 million jobs worldwide.
Hydrochloric acid. What is hydrochloric acid? Hydrochloric acid, also known as muriatic acid, is a colorless and highly pungent solution of hydrogen chloride in water. It is a gas at ordinary temperature and pressure. Also, hydrochloric acid is classified as a strong acid. Hydrogen chloride can be formed during the burning of many plastics. Upon contact with water, it forms hydrochloric acid. Both hydrogen chloride and hydrochloric acid are corrosive. It is also found in diluted amounts in the stomach of humans and animals as gastric acid. It is a component of the gastric acid in the digestive systems of most animal species, including humans. Hydrochloric acid, although not manufactured in such large quantities as sulfuric acid, it is an important laboratory reagent and industrial chemical. Other name: aqueous solutions of it are known as hydrochloric acid, or if the HCl in solution is of the commercial grade, as muriatic acid or spirit salt. Properties of hydrochloric acid. Physical properties. Hydrochloric acid is a clear, colorless solution and has a very caustic odor. Consists of hydrogen chloride, a gas dissolved in water. It is available in many different concentrations in water, thus its exact physical properties, such as boiling point, melting point, and density, vary accordingly. Chemical properties. Hydrochloric acid is a strong monoprotic acid, which means it can release only one H+ ion. Being a strong acid, it gets completely dissociated in water to give the hydronium and chloride ions. It readily reacts with bases to form chloride salts. Concentrated HCl dissolves many metals and forms oxidized metal chlorides and hydrogen gas. Dilute HCl can break down or digest many chemical and biological samples. Reaction with organic and inorganic bases exothermically. Hydrochloric acid reacts exothermically with organic bases such as amines and amides and organic bases such as metal oxides and hydroxides. It reacts exothermically with carbonates, including limestone and building materials containing limestone, and hydrogen carbonates to generate carbon dioxide. When hydrochloric acid reacts with an organic base, it forms a hydrochloride salt. Hydrochloric acid was historically produced from rock salt and green vitriol and later from the chemically similar common salt and sulfuric acid. Acids are neutralized by reaction with metals, oxides, hydroxides, or carbonates to form salts and other products. Reaction with sulfides, carbides, borides, and phosphides. Reacts with sulfides, carbides, borides, and phosphides to generate toxic or flammable gases. Reaction with many metals. Reacts with many metals including aluminum, zinc, calcium, magnesium, iron, tin, and all alkali metals to generate flammable hydrogen gas. History of hydrochloric acid. In 800 Common Era, Jabir Hayyan was first discovered hydrochloric acid by mixing common salt with vitriol, also known as sulfuric acid. Jabir is mostly known for his contributions to chemistry. He discovered many important chemicals and recorded these findings in over 20 books, which carried this chemical knowledge of hydrochloric acid and other basic chemicals for hundreds of years. Jabir's invention of the gold-dissolving aqua regia, consisting of hydrochloric acid and nitric acid, was of great interest to alchemists searching for the philosopher's stone. In 15th century, Basilius Valentinus described the production of hydrochloric acid by acidifying brine of common salt or sodium chloride. Basil Valentin had considerable chemical knowledge. He showed that ammonia could be obtained by the action of alkali on sal ammoniac, or ammonium chloride. In 17th century, Johann Rudolf Glauber prepared hydrochloric acid from common salt and sulfuric acid. He was first to produce concentrated hydrochloric acid in 1625 by combining sulphuric acid and table salt. In the year 1772, Joseph Priestley of Leeds discovered hydrogen chloride, which he called marine acid air. This was made by heating copper with spirit of salt, but he eventually realized that the marine acid air was simply the fumes of the spirit of salt. In the year 1818, Humphrey Davy of Penzance proved that the chemical composition included hydrogen and chlorine. When Davy decomposed hydrochloric acid, then known as muriatic acid, he found that it consisted solely of hydrogen and chlorine. During Industrial Revolution, Nicolas Leblanc's demand for alkaline substances such as soda ash increased in Europe, and the new industrial soda process. He developed the process for making soda ash, sodium carbonate, from common salt or sodium chloride. This process, which bears his name, became one of the most important industrial chemical processes of the 19th century. Moreover, in the Leblanc process, salt is converted to soda ash using sulphuric acid, limestone, and coal. Hydrogen chloride is released as a byproduct. And early in the 20th century, Leblanc process was effectively replaced by the Solvay process without the hydrochloric acid byproduct. Uses of hydrochloric acid for food production and processing. The food industry uses hydrochloric acid to process a variety of food products such as corn syrups used in soft drinks, cookies, crackers, ketchup, and cereals. Hydrochloric acid is also used as an acidifier in sauces, vegetable juices, and canned goods to help enhance flavor and reduce spoilage. For regeneration of ion exchanger. Hydrochloric acid is more efficient than sulfuric acid to regenerate a strongly acidic cation exchange. For oil and gas industry, hydrochloric acid is used in large quantities as a borehole drilling agent. This fracture stimulation fluid reduces the pH of drilling fluid systems and helps dissolve rock during drilling for the oil and gas industry. Also, hydrochloric acid is used in the activation of petroleum wells. For steel production, hydrochloric acid is a strong, corrosive acid that can be used industrially to process steel used in the building and construction industry. For calcium chloride production, calcium chloride production process basically consists of limestone reaction with hydrochloric acid. It can be also produced as byproduct from Solvay process for soda ash. Calcium chloride solution can be produced by the neutralization of aqueous hydrochloric acid with calcium carbonate. For pH control, hydrochloric acid is supplied in liquid form of varying strengths. It is used for pH control when the pool water is treated with sodium or calcium hypochlorite. Hydrochloric acid can be used to regulate the acidity of solutions. Lastly, for leather processing. Hydrochloric acid is one of the substances used in the leather process. Hydrochloric acid was used to stop the development of bacteria and maintain the proper pH level of leather. Hydrochloric acid market. Most of the hydrochloric acid is produced from the chlorination of a wide variety of organic chemicals. It is an essential product of the chemical industry and used in many industrial processes such oil well oxidizing, food manufacturing, producing calcium chloride, or processing and steel pickling. As for regional analysis, first, Asia Pacific is estimated to have dominated the global hydrochloric acid market. with China, India, and ASEAN countries being the prominent markets in the region. The hydrochloric acid market in Asia Pacific is expected to be the fastest growing during the forecast period, owing to increasing manufacturing activities, growing population, and developing industries such as food, chemical, and textile in India and China. Second, North America is expected to be the second largest market for hydrochloric acid. The North America market is expected to witness moderate growth during the forecast period. This growth can be attributed to increasing investment in hydraulic fracturing activities, growing construction industry, and increasing investment in the pharmaceuticals industry. Third, Europe is expected to be another prominent region for the hydrochloric acid market. The hydrochloric acid market in Europe is poised to witness steady growth backed by the growing chemical industry and increasing demand from food and beverage industry. Germany, UK, Italy, and French are expected to be a key market for hydrochloric acid in Europe. Fourth, the Middle East and Africa hydrochloric acid market expected to witness moderate growth primarily owing to increasing investment in oil and gas and steel industry in the region. As for segmentation analysis, global hydrochloric acid market has been segmented based on application, end-use industry, and region. Based on application, the global hydrochloric acid market has been categorized as steel pickling, oil well oxidizing, ore processing, food processing, calcium chloride, and others. By end-use industry, the global hydrochloric acid market has been divided into food and beverages, pharmaceuticals, textile, steel, oil and gas, chemical industry, and others. The global hydrochloric acid market by region has been segregated into North America, Latin America, Europe, Asia Pacific, and the Middle East and Africa. Market overview of hydrochloric acid. The hydrochloric acid market was valued at around $950 million in 2020, and the market is projected to register a CAGR of over 5% during the forecast period. The COVID-19 pandemic had an adverse effect on the global economy, which includes disruption of the supply chain. Due to lockdown regulations and a deficient number of workers, the production in various chemical and other industries declined, and the supply of raw materials to the industries decreased. Several countries have been under complete lockdown, many factories running on minimal staffing or even closed temporarily. The levels of activities were very low, and many project schedules changed or postponed. Due to all these interruptions, except the healthcare sector, other end users started delaying non-essential purchases and disengages from the consuming processes by postponing their demands for hydrochloric acid. By end user industry. Over the medium term, the major factors driving the growth of the market studied are increasing demand from the oil and gas industry and growing demand for pickling in the steel industry. Hydrochloric acid is used in the pickling process in the steel industry. Pickling is a process used for the removal of impurities such as inorganic contaminants, stains, rust, or scale from ferrous metals, copper, precious metals, and aluminum alloys. From 1964, hydrochloric acid has replaced sulphuric acid in many steel pickling facilities. Owing to this, the requirement for hydrochloric acid increased from various steel production facilities. The steel industry is the major end-user industry of hydrochloric acid. According to World Steel Association, global crude steel production in the year 2020 has reached 1,864 million tons, down by 0.9% compared to 2019 due to pandemic, and is expected to increase during forecast period. The major quantity of steel is produced in the Asia-Pacific region in countries such as China, Japan, and India. By geography, in the Asia-Pacific region, China is the largest economy in terms of gross domestic product. The country witnessed about 6.1% growth in its GDP during 2019, even after the trade disturbances caused due to its trade war with the United States. The economic growth rate of China in 2020 was initially expected to be moderate as compared to the previous year. However, due to the onset of COVID-19 in 2020, the economic growth of China is estimated to contract to some extent and is expected to witness recovery in 2021. In the oil and gas industry, hydrochloric acid is commonly used in the stimulation of oil and gas wells, particularly in carbonate formations. With increasing demand in countries like China and India, oil and gas companies are planning on expanding their manufacturing activities, resulting in the increased consumption of hydrochloric acid. With the growing population in India, developments are taking place in the industries such as food, chemical, and textile, thereby increasing the market for hydrochloric acid.
Let's now proceed to the manufacturer of hydrochloric acid in the Philippines. What is it? So we have the Mabuhay Vinyl Corporation. It is one of the Philippines' leading providers of chemical products and related services for enhancing life and preserving the environment. Mabuhay Vinyl Corporation derives its products from one of the most basic things on earth, and that is the salt from sea water. Furthermore, Mabuhay Vinyl Corporation is the lone chlor-alkali producer in the Philippines. It is the country's manufacturer of caustic soda and hydrochloric acid and the only company that produces chlorine in commercial quantities. This company has 26-hectare complex located at Assumption Heights, Buroon, Iligan City. In addition, it supplies more than 50% of the country's requirement for sodium hypochlorite. The products end up in the manufacture of many useful consumer products that are important in our daily lives. So here are the top companies in the global hydrochloric acid market. Number 1, the BASF. BASF was founded in the year 1865 and is currently headquartered in Germany. BASF is known to be the largest chemical producer in the world. The company's products and solutions primarily aim at conserving resources, ensuring good nutrition, and improving quality of life. Their product portfolio includes chemicals, plastics, performance chemicals, catalysts, coatings, crop technology, crude oil, and natural gas exploration and production. BASF offers hydrochloric acid in various grades, meeting always highest purity standards. The second one is the Merck KGaA. Having a rich history of over 350 years, Merck KGaA is the world's oldest operating chemical and pharmaceutical company in the world. Merck KGaA is a global company with approximately 53,000 employees spanning across 66 countries. In the year 1967, the company initiated its involvement in liquid crystals. leading to its market-leading role today. Liquid crystals account for a major chunk of the company's profits at present. Currently, the company is the world leader in producing liquid crystals for flat TVs and monitors. So this company, sila ay nagpo-produce ng mga liquid crystals na ginagamit for flat TVs, sa mga monitors natin, na kung saan these liquids are produced in a high standard machine. The third one is the Kemira. Kemira was founded in the year 1920 in Finland. In the initial years, the company focused on meeting the growing needs for chemistries in the industrial, mining, and fertilizer sectors. Over several decades, the company gained expertise in several including paints, pigments, manufacturing, textile fibers, and other materials. The company's pure hydrochloric acid is made by using membrane-grade chlorine, hydrogen, and demineralized water. And the fourth one is the Thermo Fisher. This American biotechnology product development company was founded in the year 2006 by the merger of two companies, Thermo Electron and Fisher Scientific. The company currently operates in over 50 countries with a total workforce of approximately 70,000 employees. One of the key features of the hydrochloric acid offered by this company is that it is packaged in ampoules to eliminate contamination and ensure product integrity. So these are the raw materials in manufacturing hydrochloric acid. The raw material in manufacturing hydrochloric acid is the gaseous hydrogen chloride, which is mixed in water. And the possible sources for this hydrochloric acid are the following. We have first the hydrogen chloride released from volcanoes, and the second one is the hydrogen chloride formed during the burning of many. Production process of hydrochloric acid. Hydrochloric acid is manufactured by various methods as follows. So what are these? First, we have synthesis from hydrogen and chlorine. Second, from salt and sulfuric acid. Third, as byproduct from chemical process. The fourth, from incineration of waste organics. And the last one is the hydrochloric acid solutions. So from these methods, we will only be focusing to the first three steps or method. We have the synthesis from hydrogen and chlorine and from salt and sulfuric acid. So the first step in manufacturing hydrochloric acid is by synthesis from hydrogen and chlorine. There is large demand in the market for water white acid. Such acid is obtained by synthetic method, and most of the plants are based on this process. The raw materials are the following. We have for the basis 1,000 kg of hydrochloric acid with a 98% yield. We have hydrogen 28.21 kilograms, and for chlorine 999.21 kilograms. So in the sources of raw material, we have both hydrogen and chlorine can be obtained during electrolysis of brine for manufacturing NaOH or sodium hydroxide. So the reactions needed will be 1 molar of hydrogen reacts with 1 molar of chlorine to yields 2 hydrogen chloride. Okay, So here is the simple process flow diagram in manufacturing of hydrochloric acid from synthesis of hydrogen and chlorine combustion. So as you can observe in this diagram, the hydrogen is burning in the presence of chlorine gas here in the combustion chamber. So as the combustion of hydrogen takes place with the presence of this chlorine gas, there will be hydrochloric acid vapors produced. So may mapoproduce dito na hydrochloric acid vapors. And then these vapor are passed through this cooling coil. Ayan. Pupunta siya dito. Magpapass siya. And then the vapors are condensed into liquid to form the hydrochloric acid. Ayan. Dito. Ayan. So from cooling oil, mako-condense siya to form liquid hydrochloric acid. So here, the cold water is introduced in a shower form. So yan dito. In a shower form yung cold water. And in addition to this, the dilute acid or water is also introduced to enter currently to dissolve these vapors. So this dilute acid or water will also enter to dissolve vapors of hydrochloric acid. Yung kaninang hydrochloric acid vapor na pumasok dito. So the dilute acid, siya yung magdi-dissolve doon sa mga vapors na yun to produce also liquid hydrochloric acid. So dito nga siya. So lahat ng mapoproduce na liquid hydrochloric acid will be going here dito sa may storage tank of hydrochloric acid. And then the exhaust gas which are free from these hydrochloric vapors are released through the exhaust fan. So yung vapor gas na hindi na dissolve dito sa may hydrochloric vapors will be released through the use of this exhaust fan. So the second method in manufacturing hydrochloric acid is the salt sulfuric acid process. So in this method, the reaction between sodium chloride or the NaCl and sulfuric acid occurs in two endothermic stages. So the raw materials will be 1,000 kilograms of hydrochloric acid. So here, the sodium chloride will be 3,206 kilograms and the sulfuric acid is 2,688 kilograms. Sources of raw materials. Sodium chloride can be obtained from seawater, salt lake, and subsoil water. And for sulfuric acid, can be obtained by contact gases. So the reactions needed will be the following. Sodium chloride will be reacted to H2SO4 or the sulfuric acid to yield sodium bisulfate and the hydrochloric acid. And the second one is the sodium chloride or the NaCl will be reacted to the sodium bisulfate to produce sodium sulfate and hydrochloric acid. Okay, so this diagram is the manufacturing of hydrochloric acid from salt and sulfuric acid. So, in the first step, magkaiba yung process ng pagkuha nila ng hydrochloric acid. Compared dito, gumamit na sila ng salt and sulfuric acid. Okay, in which, as you can see in the diagram, our feed here are the salt and the sulfuric acid or the sodium chloride or the salt. the salt and sulfuric acid is introduced to the reactor. So these two feeds we have are introduced to the reactor. Then the reactor in this case is nothing but the furnace operated on fuel. So this one. Ito yung furnace natin operated by fuel. In this reactor, the byproduct, sodium sulfate, okay, this one, is removed from the bottom of the furnace. So ito yung byproduct natin, which is the sodium sulfate. And the product mixture containing hydrochloric acid vapors are passed to the cooler. So meaning may natirang hydrochloric acid vapor dito, in which it passes through here, the cooler, to the cooler. And kagaya kanina, there is water entering the cooler in a shower form. Parang kanina dun sa unang diagram, dun sa first method. There, the unreacted H2SO4, or this one, the sulfuric acid, is washed or dissolved by water. So dito nga. So yung hydrochloric acid vapor natin dito, na-dissolve siya sa water and it forms this sulfuric acid. But the remaining product of containing hydrochloric acid vapor, so may na-remain pa ditong hydrochloric acid vapor, is passed to a cooler absorber. So pumunta ulit siya dito sa may cooler absorber. So from there, the HCl, or the hydrochloric acid vapor, is absorbed in water and formed to a liquid hydrochloric acid. So dito yung na-absorb na hydrochloric acid vapor, naging liquid. Naging liquid siya, yung vapor that forms HCl already. Dito na siya, yung HCl storage natin. So kung kanina, ang nagpaano lang sa pagiging liquid ng HCl is yung water, dito naman gumamit siya ng cooler absorber for the water to become for the hydrochloric acid vapor to become liquid hydrochloric acid. And so from here, the remaining gases are passed to the scrubber. So yung remaining gases dito sa may cooler absorber, it passed to the scrubber dito. There, the HCl, the trashes of HCl, so yung mga tira-tira, yung mga dumi ng HCl, if any, are removed with the help of water. So meron ulit water dito. That's why the trashes, or that yung mga dumi na naiwan ng HCl vapor, kung meron man, ay mariremove through the help of water. And it is recycled to the cooler absorber again. Dito. Yan. And then, the remaining gases are removed to the scrubber. So meaning, nung na-recycle siya, na-recycle yung trashes ng hydrochloric acid dito, therefore, yung mga remaining gases ay bumalik ulit dito sa may scrubber. And it was removed here sa may scrubber. So kung kanina ni-recycle yung mga trashes, pumunta ulit sa may cooler absorber, ngayon, yung trash na natira dito sa may yung trash na natira ay, o yung gases, I should say, na matitira ay mariremove to the scrubber again. So it will pass again to the scrubber at doon siya mariremove yung mga remaining gases. The third method in producing hydrochloric acid is as byproduct from chemical processes. Over 90% of the hydrogen chloride produced as a byproduct from various chemical processes. The crude HCl or the hydrochloric acid generated in these processes is generally contaminated with impurities such as unreacted chlorine, organics, chlorinated organic, and entrained catalyst particles. A wide variety of techniques are employed to treat these HCl streams to obtain either anhydrous HCl or hydrochloric acid. Some of the processes in which HCl is produced as byproduct is the manufacture of chlorofluorohydrocarbons, manufacture of aliphatic and aromatic hydrocarbons, production of high surface area silica, and the manufacture of phosphoric acid and esters of phosphoric acid. So here, most of hydrochloric acid is produced from chlorination of organic chemicals with much smaller amounts derived from the other processes. So in this process, we also consider the chlorination of organic chemicals. So matatakal dito or in this process is makikita dito yung chlorination of organic chemicals. So, under siya dito sa may byproduct of chemical processes. So, for example, OxyChem produces hydrochloric acid by combining hydrogen and chlorine in acid burners. The resulting hydrogen chloride gas is then absorbed in demineralized water to yield a high purity hydrochloric acid. So generally, this material is a co-product from the production of other chemicals. Okay, so for the fourth method is from incineration of waste organics. Environmental regulations regarding the disposal of chlorine-containing organic wastes have motivated the development of technologies for burning, paralyzing the waste organics, and recovering the chlorine values as hydrogen chloride. Several catalytic and non-catalytic processes have been developed to treat these wastes to produce hydrogen chloride. So, the last method is the from hydrochloric acid solutions. Gaseous hydrogen chloride is obtained by partially stripping concentrated acid HCl acid using an absorber-desorber system. The stripper is operated at a pressure of 100 to 200 kPa or 1 to 2 atm for improved recovery of HCl. The overhead vapors consisting of 97% HCl and 3% of water is cooled to remove most of the water as concentrated HCl, and the residual water vapor is removed by drying the gas with sulfuric acid.
So the next product to be discussed is sulfuric acid. What is sulfuric acid? It is a colorless, oily, corrosive liquid produced by the reaction of sulfur trioxide with water. As what is shown in the picture, it is clear and colorless liquid. However, it is highly corrosive towards other material as it is an oxidant and has a strong acidic nature. So upon contact, it can cause severe burns, and if it makes direct contact with your eyes, it can cause permanent blindness. It is a very active chemical and at the same time, one of the most widely used. Actually, it is known as the king of chemicals, and this is because of its direct and indirect applications in the manufacture of many chemicals. It is used in the preparation of hydrochloric acid, nitric acid, dyes, drugs, and many more.
It also enters into many industries and is employed in the manufacture of fertilizers, leather and tinplate, in the refining of petroleum, and in dyeing of fabrics. It is a dibasic acid with a molecular formula written as H2SO4. So sulfuric acid is a dibasic acid because it ionizes in aqueous solution to produce 2 hydrogen ions per molecule of the acid, or in other words, it contains 2 replaceable hydrogen ions per molecule of the acid. Its available forms include dilute sulfuric acid and concentrated sulfuric acid. Sulfuric acid is generally always found in concentrated form. It is available at concentrations as high as 98%. The dilute sulfuric acid is that in which the concentration of the water mixed in the acid is higher than that of the concentration of the acid itself. So other names of sulfuric acid includes king of compounds or king of chemicals, as what is mentioned a while ago, oil of vitriol, dipping acid, battery acid, electrolyte acid, Matling acid, and dihydrogen sulfate. Next, the properties of sulfuric acid. So again, it is colorless, oily liquid with a density of 1.8 gram per cubic centimeter. So it has a high viscosity when it is not dissolved in water. Its density is almost twice the density of water because water has a density of about 1 gram per cubic centimeter. Hence, it is quite a dense liquid. Its melting point is around 10 degrees Celsius and its boiling point is very high, at temperature of 337 degrees Celsius. So as you can see, it is much higher than the boiling point of water. This high boiling point is due to the presence of hydrogen band in the acid. This hydrogen band produces greater attraction among the molecules, and sulfuric acid molecules form long chains of hydrogen bonding. So due to the greater forces of attraction, sulfuric acid is viscous and has high boiling point. So it is also soluble in water. It dissolves in water, releasing a large amount of heat. Hence, care must be taken while preparing sulfuric acid solution from concentrated sulfuric acid. And note also that you must never add water to sulfuric acid. Instead, you should add the acid to water, slowly with proper stirring. Because if water is added or poured to the concentrated sulfuric acid, it can boil and split dangerously. And this is because hydration reaction of sulfuric acid is highly exothermic. So next, sulfuric acid is widely sold in the form of various solutions of sulfuric acid in water or sulfur trioxide and sulfuric acid. The latter, called oleums, are marketed on the basis of the percentage of sulfur trioxide present. So for example, 20% oleum means that in 100 kg there are 20 kg of sulfur trioxide and 80 kg of sulfuric acid present. So let me discuss more about its reaction with water. So what will sulfuric acid does with water? Concentrated sulfuric acid has a very strong affinity for water. So the affinity of sulfuric acid for water is sufficiently strong that it will take hydrogen and oxygen atoms out of other compounds. It can also absorb water even from gases like the air, for instance, and even from hydrated salts. So when some salts have water ingrained in their structure, sulfuric acid can actually remove that water, and this is because it is strongly attracted to it. So this makes it a very good drying agent, but take note that it is very dangerous. Next, other reactions of sulfuric acid. So sulfuric acid can also undergo neutralization or acid-base reactions due to its acidic nature. So for example, is this reaction. It's the reaction between sulfuric acid and sodium hydroxide. This reaction is an acid-base neutralization reaction between a strong acid and a strong base, and their products will be salt and water. So like other acids, it can form precipitates such as barium sulfate. So if you mix it with barium, you can form barium sulfate. So let's proceed to the history of sulfuric acid. So the origin of the first sulfuric acid is actually unknown, but there is evidence that it was known prior to the 10th century. So it is mentioned from a source that the discovery of sulfuric acid is credited to the 9th century physician and alchemist Ibn Zachariah al-Razi, who obtained the substance by dry distillation of vitriol and alcohol. And in the 15th century in Germany, a Benedictine priest and secret alchemist known as Basilius Valentinus was among the first recorded manufacturers of sulfuric acid. So it is assumed that he most likely produced the acid by burning naturally occurring sulfur with potassium nitrate, or what is also called as saltpeter. So Valentinus' methods carried on long after he died into the 18th century. Although the method had been gradually improved upon, the acid was now formed by the combustion of sulfur in bell-shaped earthen containers, where the sulfur dioxide formed by the reaction was absorbed by water that was also added during the reaction. So later on in the century, the earthenware vessels were replaced with glass jars. A major improvement made on the reaction was that of the use of catalysts to speed up the reaction. And sometime in the 1600s, alchemists found that saltpeter, an ingredient in gunpowder, increased the rate of this reaction. In 1746, in Birmingham, England, a man by the name of John Roebuck invented the lead chamber process. So in his new process, he used chambers lined with lead to produce the acid, and this effectively replaced the previous and highly fragile glass containers and earthenware vessels that were used to produce the acid. So this was the first process that allowed for the mass production of sulfuric acid. So finally, in 1831, a British vinegar merchant named Peregrine Phillips developed the contact process. So Phillips' process eventually replaced the lead chamber process and allowed for an increase in the amount of sulfuric acid produced. However, sulfuric acid was not in very high demand at the time of the conception of the contact process, and therefore its usage for large-scale industrial purposes did not begin until much later, when the acid began to become a staple constituent in the manufacture of synthetic dyes. So next is in the explosives production. Sulfuric acid is one of the components required for the preparation of explosives. TATP, or triacetone triperoxide, is an explosive which is prepared by taking hydrogen peroxide, acetone, and sulfuric acid as the basic raw materials. So next is in pharmaceutical industry. Sulfuric acid finds a wide range of applications in the pharmaceutical industry. It is used as a solvent for the chemical synthesis of a variety of chemical substances, including active pharmaceutical ingredients. One of the types of pharmaceutical ingredients manufactured by using sulfuric acid are the alkylating agents, which are commonly used in the chemotherapy. Next is in the manufacture of lead acid types batteries. Sulfuric acid also finds an application in electrochemical reaction where it serves as an electrode. It is particularly used in the electrodes which make up the lead acid battery cells, which are quite commonly used in the automobile industry. Next, in the manufacture of paints and pigments. Sulfuric acid is used to prepare many dyes and pigments in coloring industry. One of the famous coloring agents used industrially is the titanium dioxide, which is prepared as a result of treatment of titanium iron oxide mineral ore, also commonly known as ilmenite, with concentrated sulfuric acid and titanium oxygen sulfate. Next is in the manufacture of paper and pulp products. Sulfuric acid is one of the raw materials in the paper and pulp industry for the production of chlorine dioxide, a powerful oxidizing and bleaching agent which is used specifically for the bleaching of water, done commonly for the treatment of drinking water. It is also used in the manufacture of rayon. Rayon is a regenerated cellulose fiber that is made from natural sources of cellulose such as wood and related agricultural products. To carry out the manufacturing, the raw cellulose fibers obtained are dissolved in an aqueous solution which contains ions of tetraamine copper. The resulting solution is then injected into concentrated sulfuric acid, leading to the formation of fibrous rayon. Next is in the manufacture of synthetic detergents. Sulfuric acid is used in the production of synthetic detergents such as LABSA or linear alkyl benzene sulfonic acid. This is also used in the preparation of acid slurry or dodecyl benzene sulfonic acid by sulfonation of benzene. This acid slurry produced is further used for the manufacture of various detergents and soap. It is also used as oxidizing and dehydrating agent. Sulfuric acid is a good oxidizing agent and is used in many chemical reactions for the oxidation of a variety of substances. Apart from being an oxidizing agent, it is also widely used as dehydrating agent for the dehydration of various sugars to form a solid black film of carbon as residue. In the agricultural industry, sulfuric acid is used in the harvesting of potatoes. A solution of sulfuric acid is sprayed on the potato fields before harvesting them to make the green tops of the potato plant dehydrated and then they eventually dry out. It makes it easy for the farmers to separate them before they could send the crop into the harvesting machine. Next, sulfuric acid also acts as a catalyst in many reactions carried out industrially. Some of the common examples of its use as catalyst includes its inclusion in the reaction involving the production of caprolactam from cyclohexanone oxime. This caprolactam is further used for the production of nylon in the textile industry. So it is also used in esterification process. Sulfuric acid is the medium in which esterification reactions take place. In chemistry, esterification reactions are used to produce a new class of organic compounds named esters as a result of the chemical reaction between an organic acid and alcohol. The reaction is catalyzed in an acidic medium provided by sulfuric acid. And lastly, in household cleaning, sulfuric acid has been conventionally used for the cleaning of toilet seats and other dirty washroom areas like drains. So let's proceed to sulfuric acid market. Market overview. So the market for sulfuric acid is expected to grow at CAGR of over 3% globally during the forecast period. CAGR means compound annual growth rate. So the major factors driving the market studied are the increasing application in fertilizers manufacturing and growing demand from chemical and pharmaceutical industries. This is according to Murder Intelligence from the report of sulfuric acid growth trends and forecast 2021 to 2026. Also, the global sulfuric acid market is fragmented with players accounting for a marginal share of the market. Few companies include KMG Chemicals, INEOS Sulfur Chemicals, Foss Agro Group of Companies, Arubis AG, and Norion. So the sulfuric acid market is segmented by raw material, end user industry, and geography. So let's start by raw material. Elemental sulfur raw material segment grabbed significant market share in 2016 and is projected to progress at the fastest rate over the forecast period. The raw material causes less pollution in comparison to pyrite ore or base metal smelters and is available in abundance in the industry. In order to restrict or curb environmental pollution, a large number of companies have adopted stringent measures to treat the emitted sulfur gas before releasing it into the atmosphere. So let's proceed to the end user industry segment. So sulfuric acid is used in various concentrations during the manufacturing of different fertilizers, drugs, and chemicals. The Indian pharmaceutical industry, which is currently valued at 38 billion US dollars, is expected to grow exponentially to reach 120 to 130 billion US dollars by 2030. So, owing to the growing applications, especially in Asia Pacific and other regions, the demand for sulfuric acid is expected to increase considerably over the forecast period. So the other end-user industry from the figure are in metal processing, petroleum refining, and others such as textile industry, automotive batteries, pulp and paper industries, and many other industries where it has wide range of applications. And lastly, let's proceed to the geography segment. So Asia Pacific region is expected to dominate the market for sulfuric acid during the forecast period. Due to the high demand from countries like China, India, and Japan from chemical fertilizer and other manufacturing industries, the market for sulfuric acid has been rapidly increasing. So the largest producers of sulfuric acid are located in Asia Pacific region. Some of the leading companies in the production of sulfuric acid are KMG Chemicals, Norion, and PVS Chemicals. China's pharmaceutical industry, which is valued at about 145 billion US dollars currently, represents the biggest emerging market with growth tipped to reach about 200 billion US dollars by 2022, thus increasing the scope of the market.
Manufacturer of sulfuric acid in the Philippines. So the top manufacturer of sulfuric acid in the Philippines is the CMC or the Chemfield Manufacturing Corporation, which is 100% owned by LMG Chemicals Corporation. So the plant is located at Calawaan, Pasig, and the main products are sulfuric acid, oleum, and sulfur flakes. CMC provides a clear solution to the critical problem of the local oil refineries, which is the recycling of molten sulfur. So yung molten sulfur kasi is a hazard in the environment, especially if it is allowed to accumulate. So, ang ginagawa ng CMC is ginagawa nilang raw material yung molten sulfur sa paggawa ng sulfuric acid. So let's take a look at the manufacturers of sulfuric acid globally. So the first company is the Mosaic Company, which is located in the United States. So Mosaic is the world's leading producer and marketer of concentrated phosphate and potash, both of which are used in the manufacturing of fertilizer. So Mosaic's facility in Uncle Sam, Louisiana is one of its principal phosphate production facilities and produces phosphoric acid, sulfuric acid, and silicon tetrafluoride. Pero kasi itong Mosaic Company is nagkaroon siya ng violation dati. So yung Uncle Sam facility kasi nila ay may tatlong sulfuric acid plants or trains which is designated as A train, D train, and E train. So, yung EPA or yung Environmental Protection Agency is nag-complain na yung Mosaic Company daw is gumawa ng modification dun sa A and D train without first obtaining pre-construction permits and installing required pollution control. Yung ginawa kasi nilang modification is nag-cause ng significant increase in sulfur dioxide and sulfuric acid mist. So, yung mga complaint na kinasa sa kanila is yung CAA or yung Clean Air Act, and then Prevention of Significant Deterioration or PSD provisions, then Louisiana Air Control Commissions, and then provision of the CAA New Source Performance Standard. Pero ang ginawa ng Mosaic is inaddress nila itong mga violations nila by installing the best available controls on that D-train, and then in-improve din nila yung existing dual absorption system nila. And then nag-install din sila ng cutting edge ng amine-based regenerative gas absorption system dun sa may A-train. And then nag-install din sila ng Continuous Emission Rate Monitoring System or CERMS sa A and D train para ma-measure yung sulfur dioxide emission. So the next manufacturer is the Potash Corporation, which is located in Canada. So from the company name itself, we can conclude that the main product is potash. So Potash Corporation is the world's largest fertilizer company by capacity, producing the three primary crop nutrients, which are the potash, nitrogen, and phosphate. So Potash Corporation is also the largest producer of potash worldwide by capacity. So Potash Corporation produces sulfuric acid at the Aurora White Springs and Jasmars facility. The next one is the Ma'aden Saudi Arabian Mining Company, which is of course located in Saudi Arabia. So dated back in June 2011, Ma'aden Phosphate Company or MPC includes a phosphate mine and beneficiation plant at Al Halamid in the north of Saudi Arabia and a processing complex at Ras Az-Zor on the kingdom's east coast, consisting of 4 plants producing sulfuric acid, ammonia, phosphoric acid, and DAP respectively. So this company is also one of the top manufacturers of sulfuric acid globally. So the last group is the Office Sheriffen des Phosphates Group or the OCP Group, which is located in Morocco. So dated back in March 7, 2019, Morocco's OCP Group and Spain's ACS Group have signed 2 contracts to build 2 factories in Jorf Lasfar, which is 120 kilometers south of Casablanca. So the project will be 2 of the largest sulfuric acid plants in the world. So the sulfuric acid will be mainly used in the manufacture of granulated phosphate fertilizers. So this figure represents the world consumption of sulfuric acid by 2020. So as we can see, mainland China has the biggest consumption of sulfuric acid, followed by North America, Africa, Latin America, Eastern Europe, and Middle East. So yung others dito comprises of Asia, ganyan, and other countries na hindi na nabanggit. So actually, China is currently the world's largest sulfuric acid producer, while Canada is the largest sulfuric acid exporter. The following are the raw materials for contact process. First is the sulfur, followed by air and then water. So the sources of sulfur and sulfur dioxide are as follows. So sulfur can be gathered from mines, and it can also be recovered from petroleum desulfurization along with hydrogen sulfide. So sulfur dioxide can be recovered from coal or oil-burning public utility stock gases, and it can also be recovered from smelting of metal sulfide ores and isolation of sulfur dioxide from pyrite. So the industrial manufacture of sulfuric acid is done mainly by 2 processes. So these 2 processes are the lead chamber process and the contact process. So for this report po, we will focus on the contact process since ito po yung pinaka-latest and pinaka-ginagamit sa industry. So the first one that we will discuss is the lead chamber process. So the lead chamber process is actually the oldest process for manufacturing sulfuric acid dated back 200 years ago. So it was actually first developed by John Roebuck in 1746. So lead chamber process actually remained a standard method of production for sulfuric acid for almost 2 decades. So it was so robust that even as late as 1946, the chamber process still accounted for 25% of sulfuric acid manufactured. So the classic lead chamber process actually consists of 3 stages, which are the Glover Tower, lead chambers, and Gay-Lussac towers. So these stages are discussed one by one in the next slides. So let's start with the first stage of lead chamber process, which happens in the Glover Tower. So the process starts with hot sulfur dioxide gas entering at the bottom of a reactor called the Glover Tower, where it is washed with nitrous vitriol and mixed with nitric oxide and nitrogen dioxide gases. So actually, Glover Tower has 2 functions, which are the concentration of the chamber acid and the stripping of nitrogen oxide from the liquid to the gas or denitration. So concentration of chamber acid, which is usually around 62% to 68% sulfuric acid, is achieved by the hot gases entering the tower which evaporate water from the acid. So some of the sulfur dioxide is oxidized to sulfur trioxide and dissolved in the acid wash to form tower acid or Glover acid at about 78% sulfuric acid. So the dissolved nitrogen oxides are stripped from the acid and carried with the gas out of the Glover Tower into the lead chamber, which is actually the second stage. So let's proceed to the second stage of the lead chamber process, which happens in the lead chamber. So from the Glover Tower, a mixture of gases is transferred to a lead-lined chamber where it is reacted with more water. So, yung chambers na yun is the lead chambers. So, lead chambers may be a large box-like room or an enclosure in the form of truncated cone. So, yung sulfuric acid is formed by a complex of series reaction and it condenses on the walls and collects on the floors of the chamber. So actually, yung lead chambers kasi pwede siyang magkaroon up to 3 to 12 chambers wherein yung gases passes through in each chamber in succession. So the acid produced in the chambers, often called chamber acid or fertilizer acid, contains 62% to 68% sulfuric acid. So the last stage of lead chamber process happens in the Gay-Lussac tower. So yung gases natin from the previous chambers are passed into a reactor which is the Gay-Lussac tower, where they are washed with cold concentrated acid. So yung nitrogen oxides and unreacted sulfur dioxide dissolve in the acid to form nitrous vitriol used in the Glover Tower. So actually yung waste natin na nanggagaling sa may Gay-Lussac Tower is dini-discharge na lang siya sa atmosphere kasi hindi naman siya toxic or hazardous. So, product acid at a concentration of 78% sulfuric acid is drawn from the cold acid stream that is circulated from the Glover Tower to the Gay-Lussac Tower. Also, yung nitrogen losses natin are made up with nitric acid which is added to the Glover Tower. So, ito po yung diagram ng lead chamber process natin. So, let's proceed with the contact process. So, yung contact process po is actually the latest and the most widely used process in producing sulfuric acid po. So, The reason for this is because the acid produced in this method is in high concentrations needed for industrial processes. So the following are the equipments used in producing sulfuric acid by contact process. So the equipments are sulfur burner, centrifugal pumps, blowers, drying towers, waste heat boilers, electrostatic dust precipitator, heat exchanger, four-pass converter, economizer, and absorbing tower. So, i-discuss po natin to isa-isa in the next slides. So, let's start with the sulfur burner. So, ganito po yung itsura ng ating sulfur burner. So, dito po sa burner na to, yung temperature is around 1,000 to 1,200 degrees Celsius po. So, ang nangyayari dito is yung dry air, pumapasok po siya dito sa may burner, and then magre-react siya with molten sulfur to produce or to give sulfur dioxide. So, the next one is the centrifugal pump. So, meron tayong dalawang centrifugal pump na ginagamit sa contact process. So, the first one is the sulfur pump and the second is the acid pump. So, para saan ang sulfur pump? So, yung sulfur pump is ginagamit siya to prevent the sulfur from cooling and solidification. While yung acid pump naman is ginagamit to circulate the acid over the drying and absorption tower. Next is the blower. So the blower is used to propel the air at high pressure, which will react with sulfur in a burner. So blower is actually the major energy consumer. So next is drying tower. So from the name itself, drying tower is used to remove moisture from air by sulfuric acid, which is about 93 to 98%. So let's take a look naman po sa waste heat boiler. So actually, meron po tayong dalawang boiler na ginagamit dito. Yung una po, ang ginagawa niya is minemaintain niya yung temperature ng sulfur dioxide and then pinapasa niya sa precipitator. Yung pangalawang boiler naman po, ang ginagawa niya is minemaintain niya yung temperature ng sulfur trioxide which came from the second round of converter. And also po, nagproproduce din siya ng steam from sulfur dioxide and sulfur trioxide. Next one is the electrostatic dust precipitator. So, ang main role po nito is to separate the unwanted particles by electrostatic attraction po. So, ang ginagawa niya is, sineseparate niya yung dust and smoke particles from sulfur dioxide and pinupush niya into the scrubbers. So, the next one is the heat exchanger. So, the role of a heat exchanger is to provide for hot or cold split flow gas streams through exchanger shells with either mixing or splitting into two or more streams to provide for reduced condensable materials for condensation, corrosion, metal thermal differential stress, and capital equipment cost. So, ang nangyayari din dito sa heat exchanger is nag-e-exchange yung heat of sulfur trioxide by air to maintain the temperature of a four-pass converter from 600 to 450 degrees Celsius. So next is the four-pass converter. So the role of a four-pass converter is to convert sulfur dioxide into sulfur trioxide in a reversible process. So usually ginagamitan ito ng catalyst which is yung vanadium pentoxide. Also, four-pass converter operates at 450 to 500 degrees Celsius with 1 to 2 atm pressure. Next is the economizer. So, yung kasing sulfur trioxide na galing sa 4-fast converter, ang temperature niya is usually 535 degrees Celsius. So, ang role ng economizer ngayon is to control the heat of sulfur trioxide and also to produce steam. So, the last one is the absorption tower. So, meron kasi tayong dalawang tower dito. Yung dun sa una, ang ginagawa is nag-absorb ng water and then convert into oleum. And then, sa pangalawang tower is yung oleum is kino-convert na into fuming sulfuric acid. So, dun na na-form yung ating sulfuric acid. So, yung diagram na po na ito is yung nagpapakita ng overall na paggawa ng sulfuric acid using the contact process. So, para po mas maintindihan yung contact process, pwede po nating panoorin itong video na to.
Sulphuric acid is a very valuable chemical. It is used in the manufacture of detergents, dyes, fabrics, fertilizers, paints and plastics, and in many other products. But how is sulphuric acid made? Sulphuric acid is made in a three-stage process called the contact process. In stage 1, sulphur is obtained in its elemental form, a solid, it is melted and is then combusted in oxygen. What do you think is formed at this stage? Could you write a chemical equation for this? Pause, think, and continue when you're ready. The product formed at this stage is sulfur dioxide, and the chemical equation for this is shown. Did you get it right? In stage 2, the sulfur dioxide is converted into sulfur trioxide. The reaction is in equilibrium, which means that as the product is formed, the reverse reaction can also occur and it can break down into its reactants. What can be done to this process to speed it up and to force the equilibrium into forming more sulfur trioxide? Pause the video and continue when ready. This reaction can be sped up to form sulfur trioxide by adding a catalyst, vanadium oxide. This is an exothermic reaction, which means it gives out heat. Usually, this means that the formation of sulfur dioxide, the backward reaction, would be favoured at higher temperatures. However, the catalyst needs a temperature over 400 degrees centigrade for it to work, so the idea is a trade-off. The reaction actually takes place at 450 degrees centigrade. You need the gases to reach equilibrium within the very short time that they are in contact with the catalyst in the reactor. So having an increased temperature ensures a high rate of reaction, meaning you establish the forward reaction quickly. Finally, in stage 3, sulfur trioxide is converted into a very concentrated sulfuric acid, and the equation is shown now. This liquid is also known as oleum. It is very viscous and releases acidic fumes. It is very important at this stage to add water carefully, usually as a mist to sulfur trioxide. This is because the reaction is very exothermic, so mixing it with pure water would release a mist of sulfuric acid that would escape into the air. 99.5% pure sulfuric acid is then collected and is shipped off to where it is needed next. There are some acidic waste gases from stage 3 which can escape and cause local acid rain. Here's a challenge for you. What can you fit the chimney with to stop these gases from being released into the atmosphere? The correct answer is that the chimney is usually fitted with acidic scrubbers. These are bases like sodium carbonate. On contact, they neutralise the fumes, forming salt and water. Other ways to minimise the release of any sulfur oxides is by recycling gases between stages 2 and 3. In summary, the contact process converts sulfur to sulfur dioxide by combusting sulfur in air. The sulfur dioxide produced is heated to 450 degrees centigrade over a vanadium oxide catalyst. This produces sulfur trioxide. The sulfur trioxide is treated with a fine mist of water and 99.5% sulfuric acid is collected. The acidic fumes produced are treated with acidic scrubbers to prevent local acid rain.
So, let's review po kung anong nangyayari during contact process and kung ano yung mga nasa video na napanood kanina. So, sa stage 1 po, ang nangyayari is liquid sulfur is sprayed in the burner where it contacts with dry air to produce sulfur dioxide. And then, sa stage 2, yung sulfur dioxide is oxidized to sulfur trioxide by oxygen using vanadium oxide as a catalyst. And then sa stage 3, yung concentrated sulfuric acid is used to dissolve sulfur trioxide where it forms oleum in an absorption tower. And then yung last stage is yung oleum is then mixed with water in order to obtain sulfuric acid. So, paano natin maa-attain ang maximum yield in the converter? So, using Le Chatelier's principle, the equilibrium yield of sulfur trioxide should increase when the temperatures are low. So, kailangan natin ng low temperature kasi nga yung reaction is exothermic. Also, maa-attain din natin ng maximum yield kapag yung pressure natin is mataas and also kapag yung excess reactants are present. So, paano naman natin maa-attain yung high rate of reaction? So, maa-attain natin yung high rate of reaction kapag temperature is high, the pressure is high, and of course, when a catalyst is being used. So now, let's compare the advantages and disadvantages of the two processes. So, for contact process, yung advantages niya is that nakaka-produce siya ng large amount of sulfuric acid and also nakaka-produce siya ng acid with high concentrations. So, ito actually yung reason kung bakit mas ginagamit na siya sa industry ngayon, kung bakit mas ginagamit siya compared sa lead chamber process. And then, yung disadvantages niya nga lang is that the reaction is highly exothermic. And then, yung sulfur dioxide can be released to air, which can form acid rain. So, for lead chamber process naman, yung advantage niya is yung the original acid to be used can be obtained at any concentration. While yung disadvantages niya naman is, yun nga, hindi na siya widely na ginagamit since masyado na din siyang matagal and parang outdated na siya, ganon. And then, it has low concentration of sulfuric acid and then a lot of energy required for a very small yield. So, hindi siya feasible.